Hey everybody, I'm Alejandro Perez, the CGI Nerd, and in this video we're going to be taking a look at functions inside of Houdini with Python. So, I'm going to start off by opening the Python shell here, so that we can see some of the outputs, and then we're going to, actually I have a new tool here, it's edit tool, and this is what we're going to write. I was just testing it. Okay, so functions. This is kind of like a basic function. You're basically creating a blueprint of something to do. So if I apply this and I run the tool, we can see that we don't get any output at all because this is just defining a function. We just have a function, greet is hello, and then print function hello, but we're not actually executing. So the define def is how you start off a function, then you have the name of the function, in this case greet, and then any arguments. Right now we don't have any arguments, we'll look at those in a minute. Then this line we end it off with a colon, and then we go and indent the following line. Anything that is indented after this function is going to be considered part of the greeting that we're going to be working on here. So anything that is indented is going to be considered that. And then as soon as we unindent, it is going to run the function. So let's do that. Let's greet, open and close parentheses, and this is how we call the function. It will run this function. And I'm going to apply that and then run the tool, and we can see it pops up hello. Okay, so we did talk about arguments a minute ago, and here is how we set up an argument. We set up basically a variable inside of the parentheses right after the name of the function, and then here I have an f string where I'm using that argument. It's going to say hello, comma, space, and then the name of the person. And again, if I apply this and run it, we can see nothing pops up. But if we go in and unindent and call the function, you can see that here we can call the function. And in this case, I'm going to call it 2 different times, and this is where the power of using functions starts to kind of show itself. We're going to use the same line of code, but we're going to adapt it to be hello Alice and hello Bob. So let's apply this and run it, and here we go. You can see that it ran the function 2 times, one for each time we called it, and then it changed what the function did by the arguments that we put inside of the parentheses. If we wanted to, I'm going to adjust this example a little bit. Here we can give it a default value for each argument. So in here I'm going to say the default value for name is going to be equal to Jim. So if we run this without an argument here, it's going to say hello Jim. Then we're going to have the same Alice and Bob that we had a moment ago. So let's apply that and run the tool. We can say Jim, Alice, and Bob. So if you have a function that you know you're going to want to run like a way, if there's nothing inserted into the arguments, you can do that. You don't have to set a value to that. We can just give it a default value and just run the function. But if you want to be able to actually at some point in the future customize it by assigning a value, we can. Okay, let's talk about encapsulation with functions right here. So if we run this, apply and run, we can see that we get the hello Alice. Now, we did create a variable in here. We have the variable message. Let's try and print out that message. And I'm going to apply and run it, and we can see that we get an error. So why is this happening? Anything that is defined inside of the function only stays inside of the function. So if we try to print message that was created inside of the function, and now that we're outside of it, it's not going to know what that is because it's trying to encapsulate everything. And this is a way to be able to limit global functions, which is really nice because global functions can work with everything, but you want to limit the amount of global functions, if any, that you're using, because then it can confuse other code, because you might be running something and expect it to run like what we did in the previous example where we had nothing for name, but if we set a variable equal to name to something else, and then all of a sudden your function doesn't work properly. But let's say we wanted to send this out on this message variable out somehow. How do we do that? Instead of print, let's do a return. And what this is going to do is return a value. So right now, let's comment this out. Oops. There we go. And apply this and run it. So when we run it, we can see that it doesn't do anything out here. It did do something, but it's not actually printing out a value because we took out that print statement. Now what we're going to do is say message equals whatever that is, and then print message. This time we're not going to get an error. And then let's apply and run, and we can see that it prints out the message. And that's because we're using this return value. This doesn't need to be message. This could be text print. Then we'll have to change this to text print and apply and run, and you'll see that it pops up over there. So the reason this is working is that we're using that return value, and basically this that it comes out, it's going to return whatever this variable is. So this equals whatever that message return value is, and then it makes it equal to text print, and then we print that value out. Okay, let's do kind of an example like this, but with numbers. So we have x and y. The result is equal to x and y, return result. And we have to put this in parentheses. And then let us paste this here. We're calling the function. And we put 2 and 3. That means we're doing 2 plus 3. And we apply and run, and we get the result of 5. So that's kind of what we were talking about, where this holds it as a variable. This all of a sudden has a value which is now equal to this variable that we're creating, and then we're printing that value. So something to be careful with values here. Let's say we had default values equals 3 or 4, and then equals 6. Okay, and then I'm going to run this without anything, and then apply and run. So we have 4 plus 6 is 10. Now, we can, now that these have default values, we can say y equals 10. So we don't want to necessarily change x, but we want to change y. So we can apply and change this, and we can see we get the value of 14. And then let's say we did x equals 2. Apply, run, and we get 12, which is kind of what we expected. One thing that we could see here, we assign them in a different order than what the arguments are here. As long as we have the equal sign, we are fine. We can also do it as in like 2, 5. Apply, and then run the code. It gives us 7. We can do it that way. Then we could do 2 equal, or 2, and then let's say y equals 20, or 205, I guess. Apply, run, and that works. What won't work is if you go in And even if they're in the right order, say x equals that, and then we do 205. So if we apply and run this, we'll get an error. The reason for that is that you have to call anything that is positional. So positional means that you're doing it in order that it was defined over here. You have to do all those positional arguments first, and then you can define any arguments with equal signs afterwards. So if we did the reverse, like 2 and then y equals that, we'd be fine. So apply and run, and we can see that we're getting that value. So that's something to be careful. If you're doing positionals, do them at the beginning. If you're assigning the value, doing them at the end, or do all one way, do all of the other. A lot of times this is kind of a friendly way to assign values when you're working with a team of people, just putting the equal sign there so that way they know what argument, and you probably have something more descriptive in the argument's place anyways. Okay, let's take a look at a practical example. So I'm going to import Who, which is Houdini's Python module, and I'm going to import OS. OS is a way to get access to the operating system on my computer, the file paths and stuff like that. Then before I run the function, and I'm going to add a few spaces because I'm going to put the function above it, but that way we know what we're going to be working with. I need a material node. I'm going to have it selected, and once it selects it, because the who.selected nodes gives me a list of nodes, even if I have one object, it turns it into a list. I'm just telling it that I want the first item in the list. Then I have a path for my texture that I want to apply. So we're going to automatically apply textures to a material based off of a folder that we have. If you want to use the same textures that I have, you don't have to. You can use any textures really. But if you want to use the same ones, I have a link in the description. It is an affiliate link, so if you purchase the textures from there, I get a kickback from it a little bit. They're pretty good textures. I like them. So, yeah. Now let's go in and start defining the function. So, we know that we're going to need a argument for the path because we've defined a path, and we need a material. Let's create a material super quick. I'm just going to create a principled shader. There we go. So in the principled shader we have textures here. That's what we're going to be replacing. And if you hover over them, you can see the variable, the parameter, the name after that. That's the variable that we need to access when we are working with the material nodes. So that will give us a good clue on what we want. Now let's use the OS module to get access to the path. So here in the path we are going to basically find whatever files we have there, and then let's go ahead and do a for loop, which we talked about in a previous video. If you need a refresher, there is a annotation popping up right now for you. So we're going to look for image and files. This os.list directory, it's going to go to this path that we have here and then list every object or every file that is in that directory folder. And then just so that we can test it, let's print image, and let's apply, and then let's run this tool. I gotta have that selected. There we go. And oh, because we're not calling the function, let's call the function really quick. So like I said, we're just creating a blueprint here until we call it. So there we go. We have that apply textures, which is the same name here, and then we have the two variables that we created, material and path, and that's feeding into these. So let's apply this and let's try running it again. here we go. These are each one of the files that are found inside of that folder. We have an ambient occlusion, diffuse, glossiness, height, blah, blah, blah. A lot of stuff that we want to apply automatically. So if you keep the same naming convention, and here, the naming convention that we have, it's using underscores. So I basically need to know what the underscore at the end is, so that way I can use it. In this case, I do not need the .tx, I just need the .jpeg. So I can use that now. Let's start off with the diffuse material. Because we know that we have two different diffuses in here, and we want to make sure that we limit it only to the JPEG, we're going to do a condition statement. And this is kind of the way I did it, but then thinking about it later, because it's diffuse.jpg and we don't want anything else, we could actually just like limit it where we have diffuse.jpg in image. Image is the variable that is looping in each iteration. Okay, that looks good. And then what we're doing is the material parameter, base color, use texture. So again, base color, if we hover over it, we have base color, use texture. It's just checking that on, so we're setting that to true. And then we have this value here for texture. We are just assigning the base texture file. And the way we do that is we get the path, which is this path that we've defined down here. And then we put a slash, which lets us go into that folder and look at the next level of item. And this time we're looking at the path of the actual file name. These are the individual file names that we're going to be working with. And that will assign that file there. So let's apply and run it, and you can see that it goes in and assigns that texture. So we could repeat this over and over again for each one of the materials. So I am just going to copy what I have right now, except for the last couple, which I had to do a little bit different. So if I go here and just paste everything, we can see that with the same code, just adjusted for roughness, glossiness, reflection, metalness, ambient occlusion, I'm going to be applying everything onto that material. So let's apply and run the code. And now we have all those materials assigned. So the two that are just slightly different are going to be the normal and the height. And I'll show you why right now. So I have the normal and the height. It starts off the same, but then I have the scale attribute on both of these that I put in much lower than what the defaults are. So if we look at the bump, we have to enable. That's what we are turning on for the normal map, and then its texture type, it's already set to normal, so we want the texture path, and that's what we're inputting. But then we have the value of effect scale, it's set to 1, and you can see I decreased it all the way down to like negative 0.01 in order for it to kind of work with the scale of the image that we are working with. So, and then the displacement is going to be under displacement, and then we are going to do a texture displacement. That's the checkbox that we do, and then we have the effect scale and the texture. So if we apply and run this, it should apply that in there and make those changes. And if we refresh this, it might take a second, but we can see what that material looks like. There we go. It is a little dark. It might be a better idea to show you a different texture, and that will show you kind of the flexibility of this tool. So let's create another shader here, and let me get the path in one moment. Okay, so I have this folder here. This is where all of my textures for the next one is. If I go here and I just copy that path that we have there, and then select this and paste it, and oops, I need that there, and then I can apply, select this other material, and run the tool. We double check, we can see that it assigned all of the textures that we were wanting to do, and then let's refresh this, and we should see a little bit better version because this is a dark texture. This next one should be more white, like white hexagons. There we go. It's kind of dark, it works. Let's just assign it to material, that's going to be easiest. Give me a second. I'm going to create a geometry node, and here let's assign a material, do that second one, and then let's create a light in the scene, create a skylight, and then jump in and let's create a sphere, and we're going to do a UV project. That UV projection is going to be based off of polar pattern, and then let's take a look at the render. There we go. So we have that texture applied, and we can see a little bit clearer now. And if we wanted to look at the other one, we can do that. Let's just, instead of selecting that one, we can select this one, and it will update it. You can see it was much, much darker than the first one we were looking at. Alright, so that is it for this video. I hope you found it useful. This should be a pretty useful tool. As long as you keep a consistent naming convention, you can use this for all of your materials to assign textures that you are creating or that you've bought or you got from whatever source you got. So, I hope you found this useful. See you guys in the next video. Bye!